Hello. We are the Group 3.
I am Tristan.
I am Eli.
I am Alex.
I'm Audrey. And we will be talking about the basics on
Hydrocarbons. Hydrocarbons come in many types, so with our help and your attention, we can learn together about them.
In hydrocarbons, there are two main types, aliphatic and cyclic, where it's sorted down into a few more types, which we will get to soon. But first, let's learn the basics.
Hydrocarbons is an organic compound consisting entirely of hydrogen and carbon and formed when these atoms undergo covalent bonding, which they often link together in a chain or on its own.
Those can be in different configurations and sizes, and they are grouped into different types, which we saw earlier.
Now, let's go to the subtypes, alkane, alkene, and alkyne. So, what's the difference? Alkanes have a single bond between two carbon atoms, alkenes have double bonds, while alkynes have three, which is modeled here. Alkanes are the simplest form of aliphatic hydrocarbons. Mentioned earlier, it has only one bond between carbon atoms. The formula of this is CnH2n plus 2, which means that depending on the number of carbon atoms, hydrogen atoms are twice that number plus 2 more.
Here's one example, CH4, also known as methane. Why is it called methane? Because it has only one carbon atom. What if there were 2 or 3 or even 10? Here are the different prefixes for our respective number of carbon atoms. Of course, hydrocarbons have to be named, so we'll get into it now.
According to the IUPAC, there is a way to name a hydrocarbon. To help you, here's an example. Better pay attention to the sequence. First, carefully look for the parent chain, which is here. As you can see, there are 6 carbon atoms. Therefore, its prefix should be hexane.
Let's try something else. If we bump it up a little, it looks different. This branch, or substituent, also has nomenclature on their own. Starting from the end where the closest substituent is, count from there. Here, the substituent is located on the second point. Then determine the number of carbon atoms it has, in this case, 1. Therefore, the hydrocarbon displayed is 2-methylhexane. No matter what hydrocarbon, how you name it is always the same.
Meanwhile, alkenes are another type of aliphatic hydrocarbons. They have a double bond between two atoms. The formula of this is CnH2n, which means that depending on the number of carbon atoms, hydrogen atoms are only twice that number. Naming them is the same, but with additional steps.
After locating the parent chain, locate the double bond and start counting from there. The position of the carbon is indicated with a lower number for each double bond in the chain. In this case, the lower number here is 1. Therefore, this hydrocarbon is called 4-methyl-1-pentene. Don't forget, when locating substituents, always refer to the location of the double bond.
Finally, the last type of the aliphatic hydrocarbons is the alkynes. These have a triple bond between 2 carbon atoms. The formula of this is CnH2n minus 2, which means that depending on the number of carbon atoms, hydrogen atoms are twice the number minus 2. Naming alkynes is basically the same in each step as the alkane, but uses the suffix Y and E, which indicates a triple bond.
After all of these, let's talk about the second type of hydrocarbon, cyclics, which also has subtypes alicyclic and aromatic. But for now, let's leave out the alicyclics and focus on the aromatics. But before anything else, let's talk about the cyclic hydrocarbons. They are formed when one or more series of atoms in a compound, in this case carbon and hydrogen, is connected to form a ring. In aromatic compounds, the simplest hydrocarbon is benzene, but when a methane molecule is connected to the ring, this is known as methylbenzene or toluene. Other elements can connect with the molecule, like chlorine, nitrogen, or bromine.
The process of naming is rather complicated, so make sure you pay attention. Unless they are the same element, substituents can be named by prefixes. When two branches next to each other, the prefix used is ortho. When one is spaced out once, the prefix is meta. When these branches appear opposite sides, the prefix is para.
Here is one example. Start by locating the substituents of the three branches clockwise, which is 2, 4, and 6. Then determine the element used for this molecule, which this. The resulting hydrocarbon is called 2,4,6-trinitrotoluene, also known as TNT.
Wow, what an explosive and energetic ending to this tutorial.
Yes, and it's all worth it, not to mention the knowledge that we shared to all of them.
We hope that you will share this lesson to all who wish to learn.
This has been the Group 3 with
Tristan,
Ally,
Alex,
and Audrey.
and
and we are the Group 3. Bye!